Hello and good afternoon. Thank you for tuning in to this webinar on 5G spectrum for industry verticals. It's part of a series and we'll be explaining the context about that in a short while. My name is Stephanie Parker. I work for Trust IT and I'm also Vice Chairperson of the Pre-Standardization Working Group in the 5G Infrastructure Association. I'm co-moderating this webinar this afternoon with Dr. David Lund, who is President of Public Safety Communication Europe and coordinator of the Horizon 2020 project, Broadway. So we have a great lineup of speakers today, of panelists, covering lots of different associations and technical and different viewpoints. So we have starting with the 5G Observatory, which is the place to go for market developments and rollouts of 5G. The observatory plays a key role also in helping the Commission assess progress towards Europe's 5G action plan and its implementation across the member states. Then we'll be looking at viewpoints from the automotive industry through the work that's being done within the 5G Automotive Association. Then we take a look at the industry force and the manufacturing side with insights from the 5G Alliance for Connected Industry and Automation. And then we move on to broadcasting and media with the European Broadcasting Union, and then on to some viewpoints from the French Ministry of Interior on what they're doing in terms of public safety and in general the issues around and opportunities around spectrum. And finally, we are joined in our final panel by Sebastian Euler, who's bringing us some insights into the cross-border issues from an automotive perspective. So we have some great insights. There's plenty of new insights coming this afternoon. Lots of things that are really hot off the press, more or less, as I speak. So let me just give you some background information about who we are and what we're trying to do with this webinar series. So we have 4 associations that I've just mentioned, who are all market representation partners of 3GPP, which is the main global standards organization for 5G, but not just for the only for mobile communications, but increasingly so towards industry verticals. So what we've done, we've joined forces with the technical specification group chairs and their working group chairs to work together as 4 organizations to help lower the barriers for industry verticals who want to get involved in 5G standardization. And we do that through a series of initiatives. You know, we produce practical guides to walk them through some often very complex stages and processes. We also have built an online tool, which is a standards tracker, and that acts as a bridge between the specialists in 3GPP and other standards organizations, and also obviously the industry sector specialists, so that we can bring them together. A key area there is to push for common requirements and look for commonalities and similarities across the vertical industries, and this helps drive standardization and by helping to build consensus across as many stakeholders as possible. This is a series of, we started out with a series of workshops in 2019, but with the impossibility of being able to continue the face-to-face interactions, we've moved online. This is the second in a series of webinars that will take place throughout 2020. Our first one was on 3G progress so far for releases 16 and 17, but obviously looking now towards release 18, where the industry verticals have the opportunity to take forward what's already been done across verticals and bring in their brand new requirements. So this is who we are as a group of people. So myself, I'm part of the 5G public-private partnership. So on the actual public side, so the European Commission funding side, we work very closely with colleagues in the 5G Infrastructure Association. And on the other side, we join forces with the 5GIA, 5G-ACIA and PSC Europe. We also work obviously very closely with the chairs of 3GPP TSG, the technical specification groups on all sides of 5G, so from the services and systems to the radio access and then to the protocols and the core network. And then we're joined by, we are guided by the ETSI CTO, so we have a connection there with the project coordination group in 3GPP, which is the highest level decision-making body in 3GPP. So there we are. I will pass the floor now to my co-chair, Dr. David Lund, who will introduce the panelists for today.
Thank you, Stephanie. Can you just make that screen full size, Stephanie?
Yeah.
Yeah, sorry. Okay, it's my pleasure today. Welcome everybody for joining the webinar. It's my pleasure today to join Stephanie in taking you through the different presentations and the panel discussion. It's been great over the last 18 months, almost 2 years now, working in this group, because we see the common interests and differences of opinion sometimes of the different players from the different vertical sectors of 5G. So it's great to welcome today our distinguished speakers from different verticals. So we see here the Frédéric Boujard from the EU 5G Observatory, Riza Karimi from 5G Automotive Association, Ulrich Refus from 5G ACIA, Antonia Hachikono from European Broadcast Union, my friend and colleague Gerard Camanat talking to you about public safety. That's my game, and Sebastian Euler from representing the 5G CROCO program. So Stephanie, if you want to take through the agenda.
Yes, we will. Yeah. So here's the agenda for the day. We're going to start, before we start with Frédéric, he's got lots of insights and data from the 5G Observatory, and then we'll move on to Riza. But before we do that, we're going to launch a very simple poll, which we'll read out for you, and you have a few minutes to answer that poll, and we'll share the results live. And then we'll do another one before we move on to Ulrich Refus from Nokia and the 5G ACIA. So we're looking at the manufacturing side there. And after that, we'll be listening to Antonio Archidiakono from the European Broadcasting Union, and then on to the Ministry of Interior. And then we conclude with an interactive panel discussion. Remember that if you look on your screen, it might be at the top or the bottom, there is a Q&A panel. This is where you post your questions. Feel free to use the chat also, but please, please, please post the questions inside the chat, because otherwise we might lose them, and then that means we can't answer them. So thanks also in that respect to my colleague John, who will be helping us moderate the Q&As, and we've already got some coming through. You can post them anytime. If you have a specific question for one of the panelists, then you can specify who the question is for. If it's a more general question, then there's no need to do that. So I'm just going to start launching our poll now, our first poll. It's the first of 3. So we're asking you in this question, and this will also, I'll read them out because some people might be, not everyone's joining through the Zoom app. So how familiar are you with spectrum assignments for 5G in your own country? And that also includes, like, would you know how to access or get access to 5G spectrum? So the options are very familiar. So that means you know almost everything about it, including initiatives for spectrum sharing. Quite familiar, but if you're missing a few insights, which you will get this afternoon, and not at all familiar if you have very little knowledge, which we hope the webinar will bridge that gap. Okay, this is one of the reasons. In fact, going back to what David was saying about, we're bringing together very different stakeholders. This is and different viewpoints, and obviously there are things that we need to iron out, but we also have sometimes external challenges, but we like them and we embrace them. This is part of the work that we do. Next month, towards the end of next month, we'll be publishing a report on our activities and achievements over the last 12 months. It's been a very interesting ride, and I feel privileged personally to be part of this group. It's definitely one of the most interesting things I've ever worked on. And then we'll be sort of making plans for the rest of 2020 and beyond.
Thank you, Stephanie. So apologies for that alarm noise. This is Reza Karimi from Huawei on the subject of spectrum needs for ITS. They wanted advanced use cases on behalf of the 5GAA. So as way of introduction, I'd like to first put up this chart, which many of you may be aware of. This is about cellular V2X, cellular V2X being the umbrella term for all the technologies for vehicle to everything specified in 3GPP. It consists of two modes: direct communications and network-based communications. Direct communications operates in ITS bands, such as the 5.9 gigahertz band, and network-based communications operates in mobile spectrum. And in network-based communication, we connect road users to the mobile network infrastructure through the UU air interface. In direct communications, we connect road users directly with each other through the PC5 interface. So we're looking at both spectrum dedicated for ITS and spectrum used for mobile communications in mobile bands. So with that introduction, 5GAA recently concluded a study of spectrum needs for LTE V2X and NR V2X for support of day one ITS and advanced driving use cases. ITS, of course, meaning intelligent transport systems. And we did this by looking at various use cases, looking at various road geometries, looking at geographic density of road users, characteristics of the messages communicated, and the effective spectral efficiency of the radio access technologies. And this report will be published shortly by the 5GAA. So here in this report, we describe some of the results. First, looking at direct communications using the PC5 air interface at 5.9 gigahertz. So initially, we looked at some day one basic safety use cases. And these use cases typically use continual repetitive messages. So for example, 300 bytes at a repetition rate of up to 10 hertz. There are quite a number of use cases that fall under this category. We looked at two scenarios of a dense urban intersection and a freeway, and we accounted for a range of vehicle speeds and the impact of congestion control on the repetition rate of the messages. And our analysis indicated that for these day one basic safety use cases, we need at least 10 megahertz under nominal traffic conditions. But when there are abnormal traffic conditions, we will need more. So our assessment is that we need between 10 and 20 megahertz for day one basic safety use cases. We then went on and looked at some advanced use cases. Again, we're talking about direct communications here. One of the advanced use cases which we looked at was high definition sensor sharing. This is where road users and vehicles share sensor data among each other on a continual basis. And this is something which can enable autonomous driving and is very useful for vehicles being aware of each other's status and their surroundings. We looked at a freeway scenario. We accounted for a range of vehicle densities and speeds, and most importantly, amounts of sensor data that are shared. And actually, this is an open question for industry. How much sensor data should be shared among vehicles for us to have a good situation in terms of enabling autonomous driving? So we looked at a few of the solutions presented in the literature, and we looked at the spectrum needs of these, and our assessment is that we need 40 megahertz or more for these high definition sensor sharing use cases, depending on the amount of information that needs to be shared. At least 40 megahertz and certainly more. Then we looked at some other advanced use cases, which are event triggered. Unlike the previous slide, where road users share information with each other continually, this is where road users only share information when they want to do, for example, undertake specific maneuvers. These use cases are a bit more complicated, and we're still discussing in 5GA the best methodology for calculating the spectrum needs. Having said that, our initial assessment is that for each of these use cases, the spectrum needs is unlikely to exceed several megahertz, and certainly much less than the 40 megahertz for the previous use case we looked at. And of course, because these are event triggered, the contribution of these use cases to the overall spectrum needs is somewhat stochastic. In other words, it's time variable, and at any given time, of course, you can have different numbers of use cases and different numbers of vehicles involved. And for this reason, evaluating the spectrum needs for advanced use cases is certainly not trivial. But having said that, it's clear from our studies today that the 70 to 75 megahertz of ITS spectrum in the 5.9 gigahertz band is absolutely necessary to support basic safety and advanced use cases under consideration today. And of course, this band, 5.9 gigahertz, has been globally harmonized by the ITUR for intelligent transport systems. And it's absolutely essential that ITS has access to the whole of this band. And of course, this is an emerging sector. And as we learn more about the demands of automated driving, we will assess whether we actually need more than this band in order to satisfy the requirements of the road users. So this was all about direct communications between road users. Now we move on to a different item, which is to do with network-based communications using the UU interface. And already there are some V2N, so-called vehicle-to-network use cases already in deployment using mobile spectrum. So we focused on some more advanced V2N use cases, such as teleoperated driving, obstructed view assist, and a few others. We looked at different types of deployment in rural, urban, and dense urban environments to assess how much bandwidth is needed to support these use cases. And the results are summarized in this table. If you look at some of the tables at the top, such as software update or vehicle disengagement reports, these are delay tolerant, and their requirements are such that there are several megahertz, maybe approaching 10 megahertz in rural areas, but broadly speaking, they can be supported in current spectrum holdings of the mobile network operators. Once we look at some of the more advanced use cases like teleoperated driving, as you can see, the spectrum needs become several tens of megahertz and maybe even approaching 100 megahertz in rural areas. And clearly, in these use cases, the spectrum needs become a substantial proportion or even exceed the spectrum holdings of many operators in any given band, especially in the mid-band spectrum. And when we look at some of the even more advanced use cases towards the bottom of the diagram, we may need several, or rather many tens of megahertz or even several hundred megahertz. And this definitely needs additional spectrum, in particular in the mid-band range of frequencies. It is possible that some of this demand could be offloaded to millimeter waves in low mobility conditions and where coverage is available, but broadly speaking, it's mid-band spectrum that's needed for these advanced V2N automotive solutions. So just drawing a close and summarizing again the conclusions of this report, we looked at direct communications, and based on our studies, we expect that the delivery of day one use cases via LTE V2X will require between 10 and 20 megahertz of spectrum at 5.9 gigahertz, and that delivery of advanced use cases via LTE V2X and NR V2X will require an additional 40 megahertz or more of spectrum at 5.9 gigahertz. And the detailed analysis of spectrum needs of some advanced event-triggered use cases is in progress, but nevertheless, what's clear from our current studies is that the entirety of the 5.9 gigahertz band, the 70 to 75 megahertz available in different regions, must be available and is essential for direct communication use cases considered today. And of course, like any emerging sector, there could be unforeseen use cases that we haven't seen today, but may need more spectrum, and we will have to monitor these as the market evolves. And finally, on network-based communications, our studies indicate that we need at least 50 megahertz of low-band spectrum below 1 gigahertz for mobile operators to provide advanced automotive V2N services in rural areas, and 500 megahertz of additional mid-band 1 to 7 gigahertz spectrum for mobile operators to support high-capacity citywide advanced automotive V2N services. And the 5GAA places a great value on the importance of V2N communications. We consider V2N and V2V, V2I, V2P communications to be complementary. And in the case of V2N, we recommend that regional and national administrations ensure the availability of sufficient spectrum for mobile communications in so-called low bands and mid bands for support of automotive use cases in the coming decade. And with that, Stephanie, I'd like to close and thank you for everyone's attention.
Yeah, well, don't just disappear just right. Thank you very much, Fraser. Don't just disappear right now. We have a couple of questions I think that you might be able to shed a bit of light on. I'll pass the floor just for a couple of minutes for this to David to moderate a quick Q&A on some of the these takeaways that you have that you're showing on your slide now.
Okay, thanks, Stephanie. Thanks, Reza. That's a very interesting presentation. Thank you. So there's a number of questions coming in. I'm going to start top to bottom, really. So first question from anonymous attendee. What number of users, vehicles or others, were assumed to arrive at the 10 megahertz spectrum needed for the day one use cases?
The number of users for the day one use cases, okay, we looked at two scenarios. One was a intersection scenario and one was a freeway scenario. The freeway scenario had a stretch of 320 meters, and the number of vehicles was of the order of 400. For the other scenario, which had a intersection rather, again, around about 350. And these information, of course, will be in the report, which will be published hopefully in a couple of weeks.
Oh, great. Look forward to reading that. Thank you. Next one from Stan Dossé. Dual SIM, dual active chipsets are developed for connected cars. Is this for redundancy or in order to connect to two different services demanding different spectrum bandwidth?
I'm not sure I'm qualified to answer that. Sorry, could you repeat? Dual SIM?
Yeah, dual SIM, dual active chipsets are developed for connected cars. Is it for redundancy or is it in order to connect to two different services?
I'm afraid I can't answer that. I'm not sure. I mean, certainly what we see in industry is that there's a need for both PC5 and UU interfaces, but we consider that this is done through a single chip and a single module. The V2N might have a SIM associated with it. The PC5 would be just direct communications. But I'm not, it's beyond my area of expertise, so apologies.
Sure, yeah. We look forward to the report still, yeah. Okay. Estimated spectrum needs of 70 to 75 megahertz. Is the overall worldwide spectrum counting all ITU regions needs, therefore, a fraction of it for a given geographical area, or should it be interpreted as required spectrum for each location where ITS services would be operating?
So our consideration is that anywhere where we have basic safety and advanced automotive communications, for direct communications rather, we really need the whole of the 5.9 gigahertz band, and that's actually 75 megahertz that's harmonized.
Yeah.
So any less than that will jeopardize the availability of definitely the advanced use cases, that's for sure, and at least 20 megahertz for basic safety.
Yeah. Okay. Thanks. Question from Dean Bubley. How much effort has been expended looking at whether some of these theoretical V2X use cases could be provided with completely different technologies and don't need 5G at all. Well done.
Yeah, Dean comes up with some very interesting questions. How much effort have we spent trying to disprove 5G? No, 5G-AA is an association which is supportive of 5G and promotes 5G. A lot of these use cases have very low latencies and therefore require access to the to the airwaves with technologies that can support low latencies. Some use cases which may need delay tolerant applications such as software download. If the software download is not essential on the road, you can do it in your garage or do it in your house. You can use other technologies. You wouldn't need 5G. But if you are on the road and your automotive system requires a critical update, then you need mobility, you need low latency, you need reliability, and that's where 5G comes in. Thanks. Okay,
thanks, Rosie. I think in the interest of time, I'll take one more question. From looking through Herman van Spreckler, what kind of network do you foresee amount of sites when you're using this amount of spectrum in this frequency band?
Sorry, could you repeat? I didn't catch that. Sorry.
Okay. What kind of network do you foresee so that the number of sites when you are using this amount of spectrum in this frequency band?
Right. So certainly in city centers, we expect similar deployments when we're talking about, so for example, for city centers or urban areas, we assumed a 500 meter ISD, inter-site distance. And that's typical of urban communications. For rural, and this is perhaps extreme rural, we've assumed 5 kilometers ISD, but along major roads, it is possible that you can have a smaller ISD and therefore smaller spectrum needs through densification of the deployment.
Okay, thank you. So, Stephanie, I think in the interest of time, should we move forward? I think the rest of the questions on there, I think we can try to answer through the chat tool maybe. Or
absolutely. In fact, I have one already from this presentation. We're going to try and just reconnect with Frederic Pujol, who is connecting by phone.
Thank you very much. Sorry for the delay. So I will present an overview of 5G deployments in Europe. The 5G Observatory was established 2 years ago by the European Commission, and IDA DigiWorld is providing it to the Commission. So the main objectives are to track the main 5G action plan from the Commission. So to track the assignment of spectrum, especially in the pioneer bands, in the 3 pioneer bands, and to make sure that there are large-scale introduction by the end of this year, and also to promote deployment in the major urban areas in Europe and also along major transport paths, and to promote pan-European 5G trials involving both operators, vendors, and verticals. So here is the first one of the 2 scoreboards that was published at the end of March this year. So it shows the progress in EU. So it's now EU 27 plus the UK, because there is this UK exiting from Europe, but we still count figures coming from the UK. So you can see the first part of the slide at the top left shows the number of 5G trials that we identified in EU 27 plus the UK. So it's close to 200 5G trials. So we have at the bottom left the amount of spectrum in the 3 pioneer bands assigned in Europe. So it's only a little bit more than 20% at the end of March this year. And we also track what the member states are doing in terms of national 5G roadmaps. So at the end of March this year, only 11 member states plus the UK had published national 5G roadmaps. Please move on to slide number 4. Okay, so in the 5G Observatory, we focus on the 3 pioneer bands, the 700 bands, the 3.6 gigahertz band, and in the millimeter wave bands, the 26. So some operators might launch 5G using existing 4G spectrum, like the 2.1 gigahertz band, or maybe the 700 band, which has been signed already in many countries, but it's likely that most countries will use the 3.6 gigahertz band. This is what we see today. And in terms of availability of this band, you can see that it's today assigned at close to 40% in the EU 27 plus the UK. The 700 band is a little bit specific because you can see that part of this band has been assigned but is not usable this year. So this is due to the situation in Italy where the 700 band is still being used by digital broadcasting. So it will be freed up at the end of this year and the operators will be able to use it soon for 5G. Please move on to the next slide. You can see on this map countries which have already assigned various frequency bands. It should be noted that the 3.6 band is the most important one because it allows the operators to quickly deploy 5G in the cities. It offers a good mix between coverage and capacity. In some countries, it should be noted that this band is being used for fixed wireless access using either 4G or mobile WAMAX. So there is still a defragmentation process in place in many member states. Here we compare the amount of spectrum which has been both identified and assigned in Europe and in other geographical areas. So you can see that there are various discrepancies between the geographical areas. Europe is the only area where 3 specific bands have been defined for 5G. In other areas, well, it's already true in South Korea for the 3.6 and the 28 gigahertz band, but in countries like the USA, it's much more complicated and operators don't have access today to mid-band spectrum and they have to use dynamic spectrum sharing in order to provide good coverage. In the observatory, we also track the private trials I mentioned earlier. So you can have access to a database and sort out using various filters such as country, operator, manufacturer, frequency band, and which vertical is participating to the trial. And you can also generate an Excel export of these trials. So we analyze the type of trials that have been identified so far. And in terms of frequency bands used for these trials, so it's really in line with what we are seeing today with commercial launches. So the 3.6 gigahertz band is used here in 70% of the trials. Today it's used in close to 100% of the commercial services. It's also interesting to see that there is some interest for the millimeter wave bands. The use of the 28 gigahertz band is mainly due to the fact that network equipment and devices were not available for the 26 band 2 years ago, but this is now changing and operators show some interest for the use of millimeter wave band for fixed wireless access. And interest for the 700 band is very limited, probably due to the very limited amount of bandwidth in the 700. If we now have a look at the type of vertical tested in these trials, so the most trial verticals were media entertainment, followed by transport and automotive. Transport cover both railways, maritime, and airways. There is, of course, a very strong interest for manufacturing. And virtual reality is also mentioned as one of the most tested vertical here. We also analyzed the number of cell sites or 5G cell sites that are installed by operators for commercial deployments. In Europe, it's in the order of magnitude of hundreds of cell sites in many countries, and especially in the mid-band, the 3.6 band. In countries like USA and Japan, coverage is for the main cities, and it uses, well, in Japan, mainly mid-bands, but in the US, it's a combination of low bands and mid-bands, and also millimeter wave bands for Verizon Wireless and AT&T. In China and South Korea, you can see here deployment of a huge number of base stations, 5G base stations. So China plans to deploy 500,000 5G base stations this year on top of the existing 5G base stations. So it's really huge. South Korea is quite close with a little bit more than 100,000 base stations already in operation. And these base stations are mainly operating in the mid-band. Okay, so now to conclude this presentation, so we can state that 5G, no, please come back on, yeah, on this one. So 5G was launched in many countries last year. It started in 2018, but with a very limited deployment by Verizon Wireless in the US. We are seeing very rapid deployments in many countries. In South Korea and China, there are already a very significant number of subscriptions. So in China, there is a debate about real 5G subscriptions because many 4G subscribers were upgraded to 5G, even though they don't have right now a 5G device. But well, let's say that it's the number of subscriptions in China should be close to 50 million and probably close to 6 million in South Korea. So it's already very impressive. Today, services that are offered are only enhanced mobile broadband. And yeah, all operators around the world are operating in non-standalone mode. The standalone mode will be coming to the market probably before the end of the year in South Korea and maybe in China as well. But for today, 5G really provides very high data rates and higher capacity for lower cost for the mobile operators. So this is the end of my presentation, and I'll be happy to answer to your questions.
So do you know whether the media entertainment trial are, as shown on slide 9 on private trials, including significant AR/VR component?
Yes, yeah. Yeah, you can get more details in the database, which is on the 5G Observatory website. But if I remember well, there were many trials involving augmented reality and virtual reality. But there were also some trials involving just broadcasting capability. So there was really a mix of various tests.
Okay, thank you. Just one more final question, I think. So how many local private enterprise 5G deployments are there in Europe, e.g. using German 3.7 spectrum, UK 3.8 to 4.2 and equivalents around Europe?
Okay, yeah, this is a very interesting question. We don't have very precise figures today. We are gathering information on that, but we've heard that a large industry company, not only in the automotive sector, but also in other industrial sectors, are now building their own private 5G network in Germany. We don't have more details today, but this is something we are going to track. Okay,
thank you very much. Okay, there is one quick final question just came in there. Is eMBB seen as the killer app?
Certainly not, because 5G will not only address the the B2C market, but there are high expectations on the B2B and B2B2C markets. So operators should be able to monetize 5G with various vertical sectors, and this will come with the standalone mode. So it's likely to be available in Europe next year and in 2022.
To my slide deck. So we're just going to have a quick poll launch right now. Okay, so I'm just going to launch the second poll and give you a few minutes. This is about spectrum coverage, and I'll read it out for those of you. Oh, sorry, I need to launch it. So the question is, how important is it to ensure dedicated spectrum for 5G use cases? You can answer this from any perspective, even if you're from the supply side. So the options are very important, quite important, not important. And we just heard as well earlier from Razer how some additional requirements are coming, are emerging from sort of ongoing research and trials and investigations. And we did actually mention private networks at our July workshop 2019, and we noticed that it's not just private networks is not just a requirement for the manufacturing sector, but also there's some cases in broadcasting where private networks are important. For example, live coverage of events like the Tour de France, but also in the utilities and and also in other sectors. So this is something that I definitely think we need to continue to talk about. Okay, we'll stop voting now. So over 70% of the participants have voted, and those are the results. So we're happy to see that it's very important. So thank you for voting. So we'll move on then now to the next part of our webinar. We're moving on to the Industry 4.0 or Industrial Internet of Things, however you prefer to call it, with a presentation from Ulrich Reifus, who is Head of Policy and Spectrum at Nokia and is also part of the ongoing work in the 5G Alliance for Connected Industry and Automation, and their work on spectrum and operating models.
So thank you very much for having me here.
Thank you for coming.
Slides are visible and I'm well audible.
You're on full mode, at least for me. Okay, thanks a lot.
Thanks.
Yeah.
Perfect.
Yeah. So 5G ACIA, well, it's spelled out actually as this Alliance for Connected Industries and Automation. So here it's really about 5G for manufacturing purposes. So on my person, I'm a rapporteur of a specific internal 5G ACIA work item, network operation and spectrum models. I'm also running for the next period for the working group 2, which is spectrum, the chairmanship. And besides that, I have roles in different other spectrum organizations or organizations looking into spectrum. So some of you may know me from there. The mission of 5G ACIA, that's to ensure the best possible applicability of 5G technology and 5G networks for the manufacturing and the process industry. And well, we need to address there, discuss, evaluate the technical side, the regulatory side, and certain business aspects. So you also see the setup, maybe most interesting, this structure in terms of working groups, where one is looking into use cases and requirements. And we had Michael Barr recently in a similar webinar presenting the status in 3GPP, where actually 5G ACIA is contributing on this requirement side. We have the working group 2 on spectrum and operator models. We have a working group 3 looking into the architecture behind that, and I'll show a little bit more about that later on as well. Then certainly the communication to the external world in the working group 4, and working group 5 looking into validating whatever is done in the other groups in actual tests. So looking into this Spectrum Working Group 2, so you see our current chairman, Jose Prats from Bosch, and Michael Färber from Intel as the vice chair of that group. It's about identification and definition of the spectrum needs. So you see a link there to requirements, so Working Group 1. It's about monitoring and contributions also to the spectrum regulatory world, where sometimes it's a bit difficult, certainly for a widespread organization like 5G ACAA with a membership having so-called OT companies, operation technologies, so meaning those companies actually doing manufacturing, looking into the application of 5G, as well as their suppliers in terms of machinery and so forth. And on the other hand, this ICT world, information and communication technology world, with mobile network operators, and then certainly the supply side like ourselves, so companies like Nokia. We're also present in certain committees towards ITUR. We have been in contact with RSPG, for instance. And then it's really about talking internally about these spectrum usage and operational models. So how can private 5G networks in a factory actually look like? So some achievements that we had in the past. So we had few submissions to ITUR in Working Party 5A, 5D, and RSPG in terms of the 5G spectrum discussions there. It's about looking, let's say, internally into what happens in this regulatory world, what conditions on spectrum assignments are there in the outside world, and what does that mean for the industry. We're also doing some research on 5G spectrum available globally. So certainly work like the 5G Observatory helps there. But we found we need to look internally a bit deeper into that. So quite a number of activities there. So these contributions to the ITUR of Working Group 2 had been some contributions to this technical report on spectrum harmonization for industrial automation in the recent World Radio Conference. And there 5G ACIA mainly worked on this use case side, contributing those. I guess most interesting here today is this work on spectrum options for 5G non-public networks, or also NPNs. You're certainly aware of certain examples. So the Germany 3.7 to 3.8 gigahertz example had been mentioned earlier on, where industry has a direct access to spectrum in form of local licenses. We have the example, for instance, of the UK with a spectrum range a bit above that, 3.8 to 4.2 gigahertz, where so-called shared licenses are available. I think a similar concept that you have an exclusive license for some local property. Japan has in place a similar thing in the millimetric wave range, in the 28 gigahertz range, but also considering some mid-band spectrum for that. So those kind of examples, but also how does it look like in jurisdictions not offering that direct spectrum access? So if we go to the next slide, so this work item that I had the pleasure to lead discussed mainly licensed bands. So typically it's assumed that license exempt bands cannot always provide the desired quality of service if you don't have full control over the medium, if you don't, if you have to, for instance, do listen before talk, that might kill your latency requirements and so forth. So the focus is on where industries can get exclusive access to spectrum within their premises where they need it. Then typically you come to a split in these band ranges. So Frederic has mentioned these 3 pioneer bands, and you can easily map them to our grouping here, where we said there are these low bands below 3 gigahertz. So those would be typically licensed to mobile operators. So those are the bands available for mobile communications today, and maybe augmented by now like the 700 megahertz band. There are these mid-band ranges between 3 and maybe then eventually up to 10 gigahertz. And then certainly the high band ranges above 24 gigahertz. And now you see these different licensing options as you go through various jurisdictions. So certainly all countries typically have these either nationwide or regional licenses. So in Europe, we have it typically nationwide, but if you go to the US, if you go to India or so, then it's typically split down into more regional structures, but still it would be always wide areas covering many, many enterprises, a lot of population and so forth. So not being specific to any particular piece of property. Within such licenses, however, quite some countries allow for leasing of spectrum. So a mobile operator, for instance, could pass on this right of use in a specific location to some other entity, but not all jurisdictions allow for that. And finally, and this is a maybe more new concept for 3GPP technologies, but certainly there have been other radio users living on local licenses, so licenses really confined to a very limited area, and maybe with this idea of really tying it to a specific property. And this certainly is an interesting concept for industrial users with defined premises. But by the way, it's also interesting maybe and that could then link into the talk of Antonio, for production purposes in the media world. So think of a movie studio or think of a musical theater where every day, every night, you need a certain set of frequencies to operate your content production equipment. So some similarities may be there even to this media world. And maybe at the core of the work have been these discussions on non-public networks. So 3GPP defines a set of options, how this can be implemented. There is a dedicated white paper, public white paper available under the link presented here. And so it ranges from this idea of a full standalone non-public network implementation. So you see the blue part, everything's basically contained in the factory with an optional connection for well, bringing in and out certain traffic from a public network. The center two pictures show how resources in the factory can be shared. So really sharing the radio access network as a whole is one option. You even see from the two colors, let's say on the transmission of the antenna, which on the one hand side can be read in a way that you have traffic from both sides on the very same base station, on the very same radio access network in the factory, which can also be read in a way that you can look into sharing spectrum resources in cases where, let's say, this local enterprise has own spectrum and there is spectrum available certainly always from the public mobile network operator side. So that could give you additional bandwidth advantages and cost efficiency advantages in the factory. And maybe a variant of that is if even the control plane of that shared radio access network is shared. And then finally, there certainly always is the option to buy the non-public network in form of a network slice from a mobile network operator. So let's say the physical implementation would be in resources of the public operator's network, but provide the functionality of a non-public network within the factory. Within this, these discussions, in internal discussions in 5G ACIA, we tried to map on the one hand side these different bands or band ranges that are available for 5G communication, and on the other hand the available regulatory models in terms of nationwide and regional versus the option of sub-licensing versus the option of direct spectrum access. And finally, you can actually build, let's say, every model depicted here in terms of a non-public network model under any of the regulatory models. Certainly, if enterprises have access to own spectrum, a standalone non-public network is fairly straightforward, can be built in own resources. It can also rely on leased spectrum. But even in jurisdictions where there is no direct spectrum access, you certainly have the possibility to have a mobile network operator build you a standalone non-public network. So these blue and red colors do not necessarily indicate who is operating what. So you even see examples, let's say the other way around, in Germany, where big enterprises have announced standalone non-public network implementations by mobile network operators in the spectrum that is licensed to these local enterprises. So basically, there's much more than black and white. I guess that's the important message. 5G is very much about cooperation to find those models where you have the biggest mutual benefits. So certainly it's always interesting for industry to look into these existing ecosystems in key bands like these EU pioneer bands, or bands being very close to that, like the 3.8 to 4.2 gigahertz range, which is also well covered by a 3GPP band definition. But then it's always also about cooperation, trying to identify where there's mutual economic benefit in the best possible cooperation model. So that would conclude my talk. I hope this had been interesting, and I'm looking forward to your questions. Thank you.
That was super insightful. Thank you very much, Ulrich. David, do we have any questions? I think there are a couple in the Q&A panel, maybe, that, or we can.
Yeah, there's one question there in the Q&A panel. Anna's question is, I think we keep that to the panel session, so because that's back on the ITS topic. So question is, use and dedicated spectrum is justified by the fact that listen before talk may not provide sufficient course. This typically refers to Wi-Fi. What about shared spectrum with slicing?
Yeah, thanks for the question. I think it touches upon different dimensions. So I guess the question, listen before talk or not, refers to indeed techniques looked into in Wi-Fi or needed for Wi-Fi. The question is more, do you have exclusive rights of use of the spectrum, and can you assume you can just access the resource, or can't you, because you have to respect with certain politeness rules other users in the spectrum? I would say licensed spectrum helps you definitely to be able to access the spectrum right away. Now, license can have very different fashions. It can be licensed to a mobile network operator, then subleased to a local entity. It can be a dedicated license from the regulator. It can be something like a priority access license in the United States, which is considered a shared mechanism. So there is a database which would guarantee you access to whatever you've licensed, to the amount of spectrum you've licensed, not necessarily on the same carrier. So there's quite some flavor to it, but certainly there is some, let's say, correlation between do you have to expect other users, and do you have to do listen before talk, or do you have immediate access to the resource by some licensing mechanism, whether it's in a shared environment or not.
Okay, thank you, Ulrich. I think that was the only question raised on the panel, so we can move forward. Stephanie.
Yeah, I think so. I think there are lots of points that for the final panel, interactive panel at the end, I think, from this presentation. So we'll leave them for that. So thanks again, Ulrich. We'll now move on to Antonio, in fact, Archidiacono, and I will just, if you can stop sharing. Thank you very much. Thank you. So it's over now to Antonio Archidiacono, who is Director of Technology Innovation at the European Broadcasting Union, and is also part of the 5G MAG, the 5G Media Group, which is the presentation that you see now. I've just been following, actually, Antonio, before you start, the EBU webinar, and something very interesting. It started at 2 o'clock this afternoon. I managed to follow it for an hour or so. But the floor is yours now. Over to you. Thanks a lot for joining us.
Thank you. Good afternoon, ladies and gentlemen. Thank you for having me here. As Stephanie said, we had another webinar this afternoon on 5G and 5G broadcasting and 5G for production in particular. So this has been quite an interesting presentation. Now I will be here representing the 5G MAG, which I'm chairing. The steering group of the 5G MAG. The 5G MAG is the 5G Media Action Group. And this is a forum that we have created to represent the media industry in the 5G world in October 2019, so it's relatively recent. And this is to the idea of representing the interest of the media industry in different instances, from the content creation to the contribution to the production, to the distribution, to the consumption. So these are the areas where we see a lot of applications for 5G, and also of the new way of having multiple layers possible into the 5G system. And this representation was missing so far, and so we are trying to do this for the media industry. But as you will see in a moment, there are also areas of cross interest there, and you see already from this picture that it is not only for the media industry, but this could be across also in the automotive industry, but also in the emergency applications and other cases. So two main areas of interest in 5G for media. One is in the area of content production and contribution. So the idea is here to enable the transition from the best effort connectivity that exists today in 4G, for example, to reliable interoperable IP wireless production using 5G. This is very important. The COVID crisis has shown that the ability to remote producing, the ability to connect reliably with guaranteed quality of service is important. So it is very, very much at the center of the actual concerns, and in fact, it is one very strong demand there. This is important also not only for media applications, but we see that the solutions that we are proposing for media applications can also be exported into other areas. And this is all to do with, for example, applications in the health environment. You can imagine that one thing that we can solve by providing a solution to connect a camera or a set of cameras with guaranteed quality and guaranteed bandwidth, it is also applicable for health applications, for remote health applications, and so on. So all these should work in mobility and in fixed applications. There are different possibilities. There is public and non-public networks, and the internet working and integration is a fundamental element. And we at 5G MAG, we are active in this. And at EBU, which I also represent here, we are very active too. We have a group where we have almost 500 members that are participating in this area, and coming from the industry and from the EBU members. And this is so one of the key areas of activity. The other area of activity is the 5G for content distribution. This is to see how we can deliver content to 100% of population, 100% of the territory, in a universal coverage. This is the mandate of the public broadcasters, but in general is needed for applications in mobility, and in particular for the automotive market, for example. And these at the same time guaranteeing a high degree of personalization. So it is one-to-many, and at the same time the possibility to personalize. The 5G gives us this possibility. And so the idea of combining unicast, multicast, and broadcast using the different 5G layers it is very important. It is key to provide a solution for media distribution. Is key for providing a solution that is sustainable, because by using broadcast and multicast capabilities, you can reduce drastically the cost of the infrastructure at unicast level, and so the cost of having to adapt to the peak in traffic for large number of users. And by combining this with the terrestrial and the satellite networks, we are also able to provide 100% coverage with a sustainable investment. So this is another important element. So it's multi-layer from the physical point of view, whether this is terrestrial or satellite, and it's multi-layer from the unicast, multicast, and broadcast point of view. Of course, the idea is to use network slicing, edge computing, and caching. So combining this with the intelligence in the network and in a cloud network architecture. So all this is kept into consideration, and this is part of what we are doing, again, in the 5G MAG. So to implement this, we have structured the 5G MAG into 4 different working groups, 2 working groups dealing with 5G for content and 5G for contribution, and for 5G for content distribution. And you see there is a working group 3, which is specifically dedicated to regulation, policy, and spectrum. As usual, this is a fundamental part. I mean, you need land where to build your infrastructures, and without the frequencies, you don't go very far. So that's a fundamental element. Then a 4th group, which is the promotion, liaison, and dissemination. This also in view of the synergies that exist with other applications other than media and with other verticals that I mentioned before. So going now specifically to the spectrum and regulation and policy related to this, the spectrum is a fundamental asset for the media industry. It is important to have media distribution with an efficient use of the spectrum resources, and to have the enough resources for both, also for production and the contribution, and for the broadcast and multicast modes, and in public and non-public networks. So this is where the assets should be. This is very important, as I said, to guarantee a universal coverage and connectivity for users. A car will go anywhere in a territory, and you need to serve with entertainment, but also with information there. And it is important to have an efficient scalability of radio and network resources. I was listening to the very interesting presentation of the colleague of 5G AA. I think and believe that by using the broadcast and multicast spectrum, there are some applications that could be very well complemented in the automotive area, and complement the V2N applications, maybe also reducing the very large requirements that are imagined when you look for a solution in pure or unicast mode. So there is possibility to say collaboration there. We are, of course, exploring the regulatory implication in terms of spectrum allocation, the licensing, and the operational and deployment models. Now, in particular, when we speak about suitable bands for media distribution, you can, of course, imagine IMT bands, downlink-only bands, but also, and of course, UHF bands as options for 5G broadcast. Some of these allocations are already being assigned. For example, in some markets, you are probably aware and familiar with a company like CBN in China that have got the 4th license in China, and they, for example, in the UHF band are planning to use the 600 megahertz band for the 5G broadcasting applications. We can also use the downlink-only transmission with the Ampere spectrum. This is existing in different bands. We have the possibility to combine what is used for mobile broadband distribution with what is used for the broadcast and multicast distribution. And then, as I already underlined, we should not forget the role of non-terrestrial networks. So the satellite networks are key in this. And if we want to serve, as I said, 100% of the coverage, the use of satellite as a complement to the terrestrial network is fundamental. So the basic rule is to use the law of physics where they work best. The basic rule is to combine and use the capabilities of 5G in terms of 3GPP specifications all across the different physical media, and also all across the different multicast, broadcast, and unicast, say, implementations. On the media production and contribution, it is important to also take into account the PMSC requirements. 5G will be, of course, fundamental for this, but there are also requirements for, in the meantime, for legacy systems. So we have to accommodate the different possible applications. We need spectrum available on premises, for example, for the wireless studios, and on the move for contribution is gathering, remote production. And as I said, lesson learned now, it is in fact, this must be available in different situations for remote production that is becoming more and more the rule more than the exception. And a close look to the regulatory model and spectrum policy for the deployment of public and non-public networks will be fundamental. And all these in a way to serve a lot of applications that are becoming mainstream and that needs to be served both for contribution and distribution in 5G. So I think I will stop here and I will take questions if you have any.
Okay, thank you very much, Antonio. We have 2 questions have come in. 3 questions are coming in. I expect 1 or 2 to jump in any minute. So let's start with first. Bottom. What is the commercial motivation that is likely to be for MNO CSPs to provide universal coverage? This is a question from Nagaraj Konda.
I mean, the universal coverage is for us fundamental, is part of the EBU mandate. We are supposed to serve 100% of the population. We are supposed to serve 100% of the territory when you are in a mobile environment. We have been doing this since ever. Today, the coverage of TV broadcasting and radio broadcasting is covering almost 100% of the population on a worldwide basis. I'm not speaking of emerging countries, but I'm speaking about worldwide basis. And this is a mandate for broadcasters that will not, and for media that we cannot abide. But if you look also at, say, other applications, if you think of, for example, the 4G coverage today in a country like UK, you have something in the order of 53 or 55% of the roads that are covered by 4G networks. It means that almost half of those roads are not covered by 4G networks. This is not imaginably acceptable in a developed world for being continuously connected. This will be even more important when we speak about autonomous driving, when we speak about connected cars, etc. So what we are proposing are, by combining the broadcast and multicast infrastructure with the unicast one, and using a multiple physical layer, terrestrial and satellite, to be able to reach 100% of the population, 100% of the territory, so to serve the whole population without discrimination, and all the mobiles, cars, but also airplanes, boats, trains, wherever they are.
Yeah. Okay, thank you. We have a number of questions starting to pour in.
Yeah.
From the participants asking the questions, we're going to have to postpone some until the panel session, if that's okay.
Yeah.
But I'll pick on one more, if you wouldn't mind a quick answer, Antonio.
Yep.
About EMBMS, how many commercial operators are planning to roll that out? How many have you got available for EMBMS?
Okay, so at the moment, as you probably know, the interest is originally has been starting from by broadcasters, public broadcasters in Europe. So we have several of our EBU members that have been already deploying trial networks in different countries. We have those in Munich area, in Paris, in Italy, in Turin. We have networks in Spain, so several places in Europe. And so these are the public broadcasters, but we have also interest from the private broadcasters. And if you look at the 40 members that are already in the 5G MAG, you can find there companies like Polkomtel, which is a telco, but at the same time a broadcaster like Polsat is the same group that are interested in this. But then you have, of course, the Chinese, for example, on one side, the CBN that I was mentioning before. They are in China, they are speaking about launching a large scale for the Olympics in 2022. It seems like yesterday, but this is very dynamic in China, despite the crisis that you have seen recently. And one of the recent announcements has been the fact that CBN is partnering with the National Grid company, which is the largest one probably in the world, to deploy those networks. And then we have had trials, for example, in Brazil, to give you another example, with the Globo people there. So this is, the interest is spread all around different continents, and we are trying to help there so that we create an ecosystem in which on one side we federate the interest of all these industries using the 3GPP standards, and at the same time we guarantee and find enough chipset manufacturers and terminal manufacturers that will implement terminals that will be able to implement the unicast, multicast and broadcast all together.
Okay, thank you very much, Antonio. Very comprehensive answer as well, thank you. So without taking any more time, let's move forward towards the final presentation from our colleague representing public safety here, Gérard Camanard from the French Ministry of Interior, who are very busy right now planning to implement a national public safety broadband mobile network. So over to you, Gérard.
I'll talk to you about public protection and disaster relief issues. I hope it will work because I am doing it with a 4G connection, because I trust our model for PPDR, so I'll do it this way. So I'll begin with some history, with the legacy paradigm of the PPDR networks. Well, PPDR users, their main purpose is not to deploy networks, is to save lives, rescue people, or arrest thieves. But to do this, we need telecommunications, and to have this telecommunication, a few years ago, the only solution was to have our own infrastructure, because MNOs didn't even exist in the 80s, and they only started in the 90s. So to do this, we need one dedicated technology, one dedicated infrastructure. We have our own teams for maintenance, and to build this, we needed spectrum. And it was rather easy to get it, because at the time competition was only between defense, rescue, and public safety. Today, it's a little bit more difficult. And to do this, we had several models. The government could be its own operator, like in France, a dedicated state agency, like Astrid in Belgium, or a commercial operator dedicated to the PPDR networks, like in UK or in Spain. But now we have to evolve to broadband. And if we keep to this same model, we'll have to invest but money only for the PPDR requirements. For example, in France, building our own broadband network would cost around 5 billion euros, and the total cost over 20 years would be between 20 and 30 billions. So we have to change. We have to change the way of building this. So now we go to 4G, and to have broadband services in 4G, we have chosen, like many other countries, to have an hybrid network. Hybrid meaning mainly using commercial coverage with MNOs. We are able today to address 98% of the population, but our needs are not only population, it's mainly territory. And with what is called in France a New Deal Mobile, with an agreement between the regulator and the MNOs, who can have 5 more years of license for the frequencies, but in exchange they have to deploy more poles and cover the white zones in 4G before 2025. It should be a win-win deal. We hope it will work, and to reach 98% of territory and not only population. So there are benefits from the improved coverage. It's an evolution in investment of the commercial networks. It's important for us, but it's not enough, and we still have some places where coverage won't be present. I just spent 2 days in the French Alps doing tests with firefighters of the Department de la Savoie, and we went to a little valley with absolutely no coverage, and we have done some exercises with tactical bubbles, and it was the only way to be able to have coverage. And to deploy this, we need spectrum, and in France, like in some other countries, today we have spectrum in the 700 band. So why do we need this dedicated spectrum? My point of view, this spectrum is first to very quickly deploy this on-demand infrastructure in case of outage or in the case of lack of coverage, like yesterday. It's a first aid kit for us, and it allows us to start something. If the operation is becoming bigger and bigger, we need more spectrum, and to do this, we have some possibilities. The licensed shared access is now a possibility. So the other possibility is to use 4G, maybe in the future 5G, private networks, and swap spectrum for service. And it's what we are building with some vital important operators, like the power company EDF in France, or some transport companies. So for the tactical networks, I'll be very quick on this because we have enough time. It's only for the sizes of the tactical bubble, but many people already know this. We have very big ones for big events, and some like rucksack, manpack, are very easy to carry. So we need solutions to be able to be autonomous when we need it and not depend on others for the mission. So which tracks do we have for spectrum in 5G? We have seen the spectrum in 4G It's called broadband, but at the scale of 4G and tomorrow 5G, it's in fact some kind of narrow bands. With 3 megahertz today, it's not much. Which would be the needs of the PPDR users in 5G? Today we don't not yet know it very well, but it will be bigger than the 3 megahertz can allow. And another question for us is how to integrate tactical networks that are deployed quickly on demand. How can we do this on the dedicated spectrum? Will the operator be able to provide us all the resources we need? Today it's a bit early to know this. Our needs in bands are not very huge, not like entertainment or even automotive industry. So the lower bands from 470 to 700 could be useful for us. And for the moment, the MNOs don't seem to be too much interested because there is not enough bandwidth for them in those bands. So maybe it could be possible. Well, I'm not sure. Because in the history of PPDR, the 4G spectrum was bestowed to PPDR and like a medal, in fact. And it was very difficult for the regulator to give us the spectrum. And it's not big. And part of the spectrum in band 68 today are not yet usable. And maybe they could have the same approach in 5G. So they will allocate the bands that are not claimed by the operators. Usually I use the farming comparison for spectrum. You have a spectrum, it's like a field in farming. You can have a crop of wheat on it, and the big flat fields with a very big yield are already used by the commercial operators. And PPDR, we only have had small fields in the mountains. And I fear it could be the same in 5G. What will be given to the PPDR users will be only the frequencies that the commercial operators won't claim. Another issue for PPDR is to use harmonize the spectrum with the Broadway project. We know that it could be difficult for PPDR users to go from one country to another without harmonized spectrum. Have it standardized for sure, and start the negotiation at international level for all the countries that are interested in having a dedicated spectrum from 5G to have this harmonized spectrum. But on the regulator point of view, spectrum is still a national issue.
Yes, thank you. I think we'll move on to the panel discussions, and we're running over a little bit. We apologise for that. I just wanted to. We'll start with the viewpoints of the cross-border issues with Sebastian Euler. I'm just going to launch the final poll very quickly, and this one is about the barriers. So, considering what we've been hearing about this afternoon. So in your view, which of the following barriers should be prioritized for industry verticals? Is it access to a harmonized spectrum, including cross-border scenarios? Is it balancing needs for both private and public networks? Is it about increased investments from MNOs? Sorry, I had a problem. Or is it skills to manage private networks? I mean, this isn't available. This won't be something relevant for everybody, but we've spotted quite a few different case studies where we do need private networks. Okay, all right, I'm going to stop now, quickly share the results. So the top answer was balancing the needs for both private and public 5G networks. Okay, so thanks a lot. I think we'll, without wasting more time, we'll move on to the panel discussion. All of the panelists taking part. We have also extra viewpoints coming from Sebastian Euler, who is senior researcher at Ericsson and is part of the 5G PPP project, 5G Croco. I think we'd like to start with you, Sebastian, if we may, and ask for your viewpoints, having heard the other ones this afternoon from a cross-border perspective and the usage of spectrum. We know the investigations are underway, but if you can share something interesting, then that would be very useful for us. So the floor is yours, Sebastian, to start the panel discussion.
Yeah, sure. So as you said, from 5G Croco perspective, the 5G Croco is a project that concentrates on automotive use cases in cross-border scenarios. And as you said, the project is still underway. It's about something like halfway done now. Yeah, regarding the spectrum work, what we have done so far is analysis of the spectrum needs of the use cases that are trialed in the project. It's an analysis that is in a way quite similar to what we have seen from the 5G AA analysis. It's just that, yeah, so we also concentrate on the use cases that we have in the project, and that is teleoperated driving, and then HD mapping. That was also in the 5G AA analysis, and then also collision avoidance. And regarding the spectrum, I think one point to make is that so these collision avoidance use case, these event-based scenarios, as it was also said before, the spectrum needs from these is really not very significant because these messages are very, very small. And even if they are repeated a few times, still the total need of bandwidth for these is pretty small. But for the other ones, HD mapping and especially teleoperated driving, we also see that the spectrum, the available spectrum, will be a bottleneck for if you want to deploy these on a larger scale. Something that we are seeing is that the main bottleneck might be in the uplink, actually, because something like TOD is a very uplink heavy use case. Or I mean, what you have there is video streaming from several cameras in the car to the network, and then a very small control and command data stream back to the vehicle. So that's something to keep in mind, because traditionally, traditional use cases usually are downlink heavy. And then, of course, if you want to come to the cross-border aspect here, so if you want to offer this service over national borders, then of course harmonization and coordination is key. And from our point of view, so I mean, if you are building if there is a new road being built, then of course there is some coordination between countries. You need to agree on where to place the road and how big the road will be, and agreeing on or coordinating what kind of network resources you provide should just be as natural as these aspects.
Okay, thank you very much, Sebastian. We wanted to ask then a more general question then to all of the audience, to the panelists this afternoon. So all regions of the world are working on spectrum allocation problems. Is anybody taking an approach that you think Europe can learn from, or even vice versa. So what do you think the best practices have emerged from this webinar this afternoon that we feel would benefit from a more global approach? So maybe we can start with Frederick, so we'll go back to the order of the presentations.
Okay. So I'll start shortly with a few remarks about spectrum assignment and allocation around the world for 5G. So it should be noted that Europe identified 3 pioneer bands, which provide a good mix of low, mid-band, and millimeter wave bands for capacity. What can be seen in other countries like the US is that spectrum sharing is also being implemented in the US, as Ulrich mentioned earlier, with CBRS. So we will probably see various solutions being implemented together with the use of unlicensed spectrum. And probably there will be a debate in Europe around the use of the 6 gigahertz band for 5G and Wi-Fi. So there is some potential here for new spectrum also. And so I guess we will be combinations of use of licensed, unlicensed spectrum, and also spectrum sharing in the coming months.
I'm happy to answer, Stephanie. Also, yes, I think Europe actually did quite well, to be fair, in terms of spectrum assignments. As was mentioned, Europe allowed pioneer bands and low and mid and high spectrum millimeter waves, where some other countries and some other regions didn't do that. And in terms of mid band, they now see a shortage. For example, in the US, the FCC decided to go for millimeter waves to begin with, and then and of course the CBRS that was mentioned, which was spectrum sharing, was a pre 5G activity. I think generally availability of spectrum for 5G is extremely important, and I think primarily this should be available for large-scale mobile networks in order to boost the ecosystem and get the infrastructure going and get 5G up and running. And that's pretty much happening across the world. In terms of spectrum sharing, I think local licensing is certainly an option for things like manufacturing, etc. And as long as that doesn't eat into spectrum for mobile operators. Specifically, this was for my Huawei hat on in terms of 5G AA. I think, again, Europe has made all of 5.9 gigahertz spectrum available for ITS, and that's quite useful. And not many regions have done that, and that's one thing we are pushing for and we are promoting globally in terms of availability of the whole of the 5.9 gigahertz for ITS. Thank you.
If I may.
Yeah.
No.
Yeah.
Mm-hmm. Yes. Thank you. Just relying on the experience that we just had with our colleague Gerard from the French Ministry that unfortunately had problems with connectivity. One thing is the availability of spectrum, and as I said in my presentation, I really believe that its spectrum is important and has been underlined, has been assigned with the best possible, strategy in Europe. But at the same time, what is important is to use the spectrum at best for what is good for, and combine different technologies and different frequency bands and different unicast, multicast, and broadcast technologies, so that we are making the best of use of the spectrum on one side, and we are also having something sustainable from the economical point of view, because it's good to have spectrum, but then if you are not having investments to cover specific areas of the territory to serve the population and to serve the mobiles, and as I said, also vehicles and so on, then you will be in a situation in which this is not sustainable, and the telcos will not invest, and any company will not invest in this. So it's always a combination of what the spectrum is, what spectrum is available, the way in which the spectrum is used and the technology that is combined within 5G, and all the tools exist there, I insist on this. And then the way in which the companies are able to invest and have a return on investment. So the complexity of the exercise is not only linked to the availability of spectrum, but is the best way of using the spectrum and the companies being ready to invest to cover large areas. So all this is a broader subject than just pure frequency availability.
Thanks very much, and I think you make some very valid points there. Maybe we need some additional incentives. I don't know, Ulrich, if you'd like to share your views on this. Thank you very much.
Thanks. I'd also like to more comment maybe from a Nokia perspective and maybe a bit more general even. So I think there is a absolute need for technical harmonization of certain bands, ideally globally, but at least on large regional levels. And CPT is doing very well in defining the block edge masts for something like 3438 as a pioneer band and so forth. But then comes the question, when do countries assign the spectrum and to whom do they assign it, under what conditions? And there we have very big variety, for instance, among CEPT members. And sometimes you certainly wish that things would go much quicker and much more harmonized. On the other hand, I think, well, we have also some competition maybe there in certain models. We see certain things working well in one country and then others can learn from that. So there I'm, well, I think harmonization also on this level is good, but maybe less necessary than on this technical level. Because on technical level, it really means filters in the end, filters in the devices. So you cannot have hundreds of frequency variants within one device, and you cannot build specific devices for small markets. And even on the base station side, it creates a lot of complexity, lots of different products. So technical harmonization and one common technical base is crucial. Now this technical base with 5G is applicable to many different sectors, as we've seen also in this webinar, people coming from very different usage angles. And there my firm belief is one needs to look into cooperative models more and more, because we're competing otherwise on limited spectrum resources. So there is quite some spectrum available for 5G. The industry works on making more spectrum even available for 5G in the upcoming World Radio conferences and then subsequently on the regional, sub-regional levels. But still, spectrum is a very scarce resource, and we need to look into how things can be best utilized. And I think public safety, for instance, has these mission critical things which may or may not justify from certain governments' point of view investment into dedicated networks, but maybe not all the video streams that need to be transmitted are mission critical, but mission supportive and could be handled in a hybrid fashion on capacity of mobile networks, which in return with that additional investment become profitable also in more rural parts of the world, thus leading to better coverage. Or take broadcast, where I think there is a heavy need for additional downlink bandwidth on mobile networks. One can look into cooperative models where infrastructure could serve not only broadcast channels in sub 700 megahertz, but also serve additional unicast capacity to the benefit of broadcasters who need to also be able to transmit non-linear content from their catch-up portals and whatsoever, and maybe Netflix or whatsoever other streaming services. And I think so it goes. And then maybe I come back to 5G ACIA, where you've seen these different models being discussed. And there will be companies, I guess, who absolutely want to rely on their own critical mission critical infrastructure, because they put mission critical services on that in their factory. So they may decide to invest money and effort and also, well, educate their own staff to be able to control all that themselves. And others say, well, there are great service providers where I can buy that exact same service from, but I'm happy not that I don't need to touch any of that. So we'll see a big variety, and I think that's also nicely actually shown in this last poll, with 47% saying that it's about this right balance of private and public activities, let's say, what can be done by the public network and where actually is it worth then spending own efforts and resources. Thanks.
Yeah, no, thanks very much, Ulrich. That's very interesting. Yeah, is that you, Gerard?
No, Antonio.
Antonio.
Sorry, just to complement what Ulrich said, that is very interesting, specifically on the sub 700 megahertz band. I think this is fundamental to protect those bands for broadcast and multicast applications. And we have been mentioning many times emergency applications, for example, on top of the broadcast for information, for entertainment, etc. And it is fundamental in emergency applications that the network that is being used is capable of serving the whole population, 100% of the population and 100% of the territory when an emergency happens. And this in a situation in which the peak of traffic will not kill the network. And this is the only solution that is possible there is to use broadcast and multicast, because this is used on a daily basis on an operational configuration able to serve as many users as necessary. And this is what will be very important and fundamental for any emergency service. So combining the availability of broadcast and multicast to reach all the people, and at the same time providing unicast services that are used not to provide a broadband large one-to-many information, but to provide the interactivity, is the only sustainable way that we have experienced for many, many years, and we need to replicate in the 5G era, being smarter, because we are allowed to be smart and switch from one to the other and combine one with the other in an intelligent way. So I think we have all the possibilities of using the law of physics and the best solutions where they are best adapted to the situation, and we need urgently to work together so that this is done to the advantage of everybody, the mobile operators, the broadcasters, the emergency services, the automotive industry, all of us together. Thank you.
Yeah, I think this continued cooperation seems to be becoming increasingly important. So thank you for that last point. In fact, our next webinar will be on public safety, so we're returning to that topic. But on top of that, we're going to add perspectives on healthcare and social care. So these are largely, the latter two are largely unexplored, at least by our group of, in terms of the webinar series. So this is certainly something that we need to take forward in future discussions with some urgency, possibly. But we did actually conceive this webinar as being a second A. And so we did actually foresee a second webinar to build on the key messages from this one, looking also perhaps at some other policy issues and possibly also at some legal aspects that might affect 5G rollouts across industry verticals in the short to mid-term. So I don't know if Gerard is with us and if he's able to make a final comment.
As I said, with you, so I think I agree with all what was said before, and I would like to mix all those answers and those point of view, because the 5G seems to be the universal technology for many usage now, and we have to take this into account on the spectrum, the global spectrum management. What I imagine today is that spectrum is like the TDM technology in telephony a few years ago. You allocate resources at one moment and you don't change it. And the needs are changing dynamically from one second to another. And maybe the spectrum management should follow this mood and be able to allocate the spectrum to the use at the moment you need it. It could be very complicated. It could be contrary to some business, because spectrum today is money. but mainly it could be the solution to meet all the different needs that are present today. That was my conclusion for this.
Thanks very much, Gerard. I don't know if there's any final word from you, David.
No, I think just final word from me. Thank you all for your valuable presentations and contributions of today. Really, I think we have a number of many more questions have been coming in, but I think we're running out of time, Stephanie. Or do we continue after? I think we're done, are we, for time?
We are. We have saved the questions, and I'm going to save a few comments and questions from the chat panel, but I will do this after ending the broadcasting, so that we don't lose any of your questions, and we will get back to you either directly in our post-event report or in the future if we feel that it's a topic that's worth discussing in a future webinar. So
yeah, I feel we could go on for 2 or 3 more hours.
We could. Yeah, I mean, this is a bigger topic. Even it's more than even we imagined it to be. Yeah, and it wasn't something that we'd explored before. But I'm so pleased that we have, because I think there's definitely more work to be done collaboratively across the associations, with the standards people, with the policy makers, and so on and so forth. But I would also like to thank very much our panelists today for their great insights, and let's carry on the debate. So just a reminder that the next webinar is on the 15th of July, probably in the morning. But as I said, it will cover these very important topics of public safety, healthcare and social care. So stay tuned as well. You'll get a follow-up message tomorrow with contact details that you can, so if you have questions or comments or suggestions for the future, you can contact us directly. So rather than going through the Zoom platform, obviously, because it would definitely get lost. So thanks again also to all of our participants. We will share all of the outcomes, as I mentioned at the beginning, and as soon as we can. So I think we can close this, David. I think it's been really interesting. I've personally learned a lot from it. And we hope that you'll be able to join us for our next webinars. So thank you. Stay safe.
Indeed. And thank you, Stephanie, as well.
Thank you, David. Yeah, thanks a lot.
Okay. Thank you very much, everybody.
Cheers. Bye-bye. Bye for now. Bye. Stay safe.